So this lecture is going to cover the lock and key model of enzyme function. So we're going to look at how do enzymes actually work. So before we get into the actual lock and key model, let's do a quick review of the definitions here that we're going to be using a lot. So the first one is enzyme. So remember that enzymes are biological catalysts, which means that they are found in living things, and because they're catalysts, they will speed up reactions, and then what's going to happen from that is we're going to create products from a chemical reaction. Those products are going to come from our substrates. So then what's our substrate? They are the reactants in our chemical reaction or our chemical equation, and they are going to be what actually bonds to our enzyme. Now, one thing to keep in mind is that enzymes are very specific, and so are the substrates. So not every enzyme will work with every substrate. Not every substrate will work with every enzyme. They fit together, and they are specific for each other. So make sure that you keep that in mind, and that'll make more sense when we look at this lock and key. The other thing that we have to know is about the active site. So this is going to be a part of your enzyme. So it's actually the part of the enzyme that the substrate is going to fit into, kind of like a puzzle piece. So one thing that has to happen, if you think about puzzle pieces, is they have to fit together. You can't just put any puzzle piece wherever you want to and try and make it fit. As much as you might try, they are made for specific spots. So the shape of your active site has to match the shape of your substrate. So just like in our picture here, we have our enzyme is this little orangish yellow Pac-Man looking guy, and it has an active site that is right here. So it's like the mouth of this Pac-Man. And you can see where the shape of that matches with the shape of the substrate. So then that will be able to fit right in there. So now let's look at lock and key. What does the lock and key model actually say? Well, so think about the locks at your house. You have a key that works in your lock, but you can't take your key to a friend's house and get in their door, because not every key is made for every lock. So it's the same idea with every enzyme and every substrate. So just like a lock will only turn with the right key, an enzyme will only work with the right substrate. So it only works with the one that fits into the active site. So you can see here we have two examples of some keys, which we're going to pretend are our substrates. So we have a good substrate because you can see from the picture here, the shape that we have here fits in there. You can kind of follow along with those curves. So that's why it's going to fit. But then we have a bad substrate. So it still looks like a key, right, that you would think would fit into a lock. But if you follow the shapes and the curves here, not exactly the same thing. So that is not going to be able to fit. So just like if you tried to use this bottom key here on a lock that it doesn't match up with, it's not going to turn. The reaction is not going to happen. So I want to show you what this whole process looks like as a whole and not just a bunch of varied steps. So the first thing is we start out with our enzyme. So here's our enzyme. This green guy is our little substrate. So my suggestion would be to kind of sketch this out a little bit. Your shapes don't have to match the ones on here exactly, but remember that the shapes do matter because the shapes on the substrate must match the shapes on your active site. And then the other thing that we have here is the active site. So remember that that is this spot right here. The shape of the enzyme that matches the substrate. So you can see it has that little triangle-y part there. So this would fit right in there. So then in our next block, the blue is still going to be our enzyme. and the green is still going to be our substrate. But what this is called when it is all together is called an enzyme substrate complex. So when they all come together, when it's one whole piece, when that substrate and that enzyme have met at your active site, that's your enzyme substrate complex. So then what happens here is my enzyme is still there, and then it's going to release my products. So I started out with this green guy here as my substrate. That was my reactants, remember? Reactants. And then I'm left with my products that I end up with here. So another thing to keep in mind is that the enzyme, the shape of the enzyme is not going to change after it releases it. So what's going to happen is now this process is going to be repeated. So the enzyme is now going to get used again. So now this whole process can occur again and again and again. So what we're going to say with that is that enzymes are reusable. So just because I use an enzyme once in one reaction doesn't mean that it's no longer being able to be used. So next thing is denaturing. So you probably remember this definition or something about it a little bit here, is that this is when the shape of the enzyme is going to change. Now, the reason why that changes can be for a variety of reasons. The one we're going to see the most is because of a change in environment. So something like the pH got too high, the temperature got too low. So what happens with this is it changes the shape of the active site. So if you change the shape of the active site, the substrate no longer fits. So it's just like if you get your locks changed, you must get a new key. So here's a drawing here for you. So you might want to just sketch something out that looks like this. So we start out, we have our enzyme and our substrate that match. So these shapes are going to fit in together. So remember, that's my active site right there that fits with the substrate. So now this enzyme, if I change the heat to be above 40 degrees Celsius, that's not optimum. That's not ideal for this enzyme for whatever reason, wherever this is found. So what's going to happen is the active site of the enzyme changes and can no longer bind to the substrate. So it has been denatured. So you can see the shape it's kind of similar, but this is not going to be able to fit in there. So go ahead and take a look at, you have some definitions and some graphing, and then some pieces to put together that represent this step right here, where you start with your enzyme and substrate separate, you come together with a complex, and then you end with your products. So go ahead and take a look at those things and let me know if you have any questions.